Hey guys, welcome to DevOps In this video tutorial, we are going to learn about Kubernetes. Kubernetes is developed by Google and it is an open source platform that automates container operations. It eliminates many of the manual processes involved in deploying and scaling containerized applications. After going through this tutorial, I promise you that the concept and understanding of the Kubernetes will be absolutely clear to you.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in DevOps certification level courses which will help you to emerge skills for a wide range of entry-level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai, and in Pune. Simply compare our many courses, find the one that suits your style and schedule best, and start today.
From now. So remaining time we'll spend with the Kubernetes. Let me tell you here, Kubernetes is very simple, very easy to do that. And Kubernetes is simple and easy only when you understand how Kubernetes works. Yes, because Kubernetes is doing a lot of work for us. Lots of automation is they are doing for us. So we need to understand how it works, and then only Kubernetes can help us to save our time and many things in the production environment. Okay, so now let's get started with Kubernetes. So Kubernetes will bring health, wealth, and happiness. Okay, health for us employees, wealth for employers, organization, and happiness for both of us. So if you really want to understand how Kubernetes will bring health, wealth, and happiness for all of us, then we need to stick to this session for the entire remaining day. Let me tell you here, I'm going to talk about lots of theoretical part of Kubernetes now, today. And tomorrow onwards, we will only discuss about the practical part of the Kubernetes. But this session, the one theoretical part is so important. If you miss it, if you skip it, if you miss part of it also, you will get stuck tomorrow and day after. And it's very difficult sometimes, to repeat multiple things. So I would request you all to be in this session and go through this. And if you find any difficulties, you can ask me now itself rather than tomorrow. So that way it will help us. Okay. So I would like to get one quick voting. How many people are available, because this is very important session and I don't want anyone to miss out. Can you please vote yourself? How many of you are available right now? Say yes in the chat box. 4, 7, 8, 9, 10. Approx 10 people have got the voting. 11, 12, 15. I think 5 more people to go. Okay, so almost 16, 17 voting I have got it. So that is good. Okay, so let's get started. So guys, we need to understand what is Kubernetes in order to understand how we can get health, wealth, and happiness. What is Kubernetes? So in order to define Kubernetes, we have to answer these 4 questions. Where did it come from? What does it do? What does the name mean? And why do we have it? So guys, it's coming from Google. Yes, it's born in Google. This tool is born in Google. And this tool got donated to CNCF in 2014 as part of the open source initiative. This tool is written in Google and source code you can find it at that GitHub. There's a website kubernetes.io. There are Slack channels and Meetup as well. Okay, so this is Google. From where it is coming from? So if you look at this image, there is one product which is called Bob, another is Omega, and third one is Kubernetes. So if you look at this, the relationship between the Bog and Omega and Kubernetes is DNA is matching. So yes, it's not evolution of the Bog and Omega, but some part of the DNA is matching with Bog and Omega. Which way? Let me tell you here. Bog and Omega is the proprietary product on which entire Google infrastructure is running. Yes. Entire Google infrastructure is running with a minimal employees. And you just imagine what are the kind of infrastructure they manage worldwide. And they are running on the Bog and Omega. So now you must be wondering, how come the Kubernetes will help us in this? So Kubernetes also can do something like that. Yeah. Kubernetes also can do something like that. Can manage entire production server, large scale production server. And that's the reason, because Kubernetes come from Google, and same time Kubernetes has something similar capabilities what Bog and Omega has. So we say DNA is matching. With that, what does the name stand for? So name stand for, it's a Greek word which is called helpsman. What is the meaning of it? So helpsman means a person who steers a ship. A person who steers a ship. In simple way, see, you have a fishing boat, very smaller size. You have a aircraft carrier also, such a large vessels. Right now, correct, 600 meters in distance. Some petroleum vessels also, 400, 500 meters in distance. Such a large vessels. So no matter whether it's a small boat or large ship, small ship or large ship, all this is managed by only one person, and that's called helpsman. So similar way, you have a production server which constitutes of one machine, two machines, 5 machines, or 5,000 machines. Kubernetes can manage it. That's the reason it says Kubernetes who can manage the entire cluster of production server for the containers. Okay, so this is the meaning of it. In short, we call it yes. So yes, it's born in Google, donated to CNCF in 2014, open source Apache 2.0 license. First ever release has happened in July 2015, written in Golang and Prometheus. So guys, did you understand what is Kubernetes? From where it is coming and what is the definition, what is the meaning of name? Any questions so far?
Is it infrastructure management tool? Can we call it?
No, we call it orchestration tool, orchestration, container orchestrator or microservices orchestrator. And that we'll get to know in the why part. So you got to know what is Kubernetes, but now we need to know why Kubernetes we need it, because there should be some justification, right? Some justification you should be having. So you should be having Kubernetes. So I have got one question in my mind. After spending 2.5 days with container, my mind is saying, why we learn container? Anyone would like to tell me why we learned container?
To deploy dependent microservices, not the use case.
No, something else. See, you spend a lot of time on the container. Why we learn container?
To save
to make the unique deployment all over the environment.
No, something else.
Maybe to reduce the the number of resources that is being used by the hardware
Application. Right. There were two I'll discuss actually. If you remember.
For scaling and
There were
the
two
time
reasons.
for hard system availability and also to start developing application faster rather than wasting time on getting the hardware part.
So there were two reasons. One is like a saving cost for running application. Same hardware run more application. So what to do? Avoid wastage. Operating system was a burden on each VM. So avoid wastage. Second thing is like a immediate release. Quick to deploy, quick to roll back. So these are the two reasons you were using Kubernetes. Docker. So now let's understand why we are needing Kubernetes. Okay. So here, containers bring scalability challenges. That's the first statement. If you want to understand why, then containers bring scalability challenges. And second statement is, we are starting to view a data center as a computer. So these are the two reasons which we have. So we need Kubernetes. But did you really understand this? Did you really understand this?
second point is, first one is something, second one is,
Let's understand this. So, see guys, you have to help me here. There is one node, there is one Docker, and in this node I can only run 4 containers maximum. That's the capacity. 1, 2, 3, 4. So this Docker is a container management, right? I said very first day. Docker manage this container. But now you need to create more container. Then what you will do?
you think this is the hardware?
We'll go for one more container.
One more container in this machine. I want to create one more node.
We have something called pod architecture installed using Kubernetes.
We'll come back slowly. I don't want to jump on the topic. Slowly we'll get into it. By end of the day, we have to complete all this discussion, whatever it is. Tomorrow we'll not spend time on this. So guys, we have got one more node. We got one more containers, few more containers. In the production, you want more containers. You want more containers. One more node. Again Docker. Just imagine, in the production, you may have hundreds of nodes, and each node you are running Docker, and each Docker is managing hundreds of their containers. Now the question is, who will manage container? Who will manage container? Who will manage container? Guys. Hello.
Docker.
Yeah. Let's make this session a little bit interactive, because it's online training. Sometimes even I find difficult if you don't respond. Okay, so I should be connected with you. So guys, Docker manage the container. In this production, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 nodes. Now the question is, who will manage? Think about it. Who will manage multiple Docker? Because Docker can manage container. Who will manage multiple Docker? Have you thought about it in the production server?
Kubernetes.
Yeah, something. That's the one problem. Second problem, guys. Tell me, load balancer. See, this is the end user. Think about it. This will hit the load balancer. Now, this load balancer, think. More than looking at the picture, think, visualize. This is Apache. This is also Apache. This is also Apache. This is also Apache. So you tell me, if I access this container to the load balancer, do you think I can load balance this container directly? Do you think? Outside of? No. Why not?
You have to go through the
We
node.
need to interact with the host.
Host, right? But guys, you said correctly. You said correctly. But let's say I expose this one at 80, this one with 80. So load balancer will balance both 80 and 81 both.
Both 80 or 80 and 81?
No, I cannot make it both 80, no, because host has only one network.
Yeah.
So I will make one 80 expose -80 with 80 and another one I expose with 81. So this load balancer will be able to balance 80 and 81 together. Network load balancer.
Yes.
Again think, how load balancer work?
The host mission. It will have the host mission.
No. What is the rule of the load balancer? Network load balancer. Guys, it has to be same port, no? You forgot that load balancer rule. IP address different, same port, no?
Okay.
Remember?
Yeah.
So in that case, it can balance either 80 or 81. So this will get wasted. This will get wasted. So that is a problem. That is a problem. Scaling is a problem for containers. You are scaling. So what is happening? Load balancer will not be able to balance with the Docker technology. So the question is, how this, think about it, how this container should have a network in a certain ways. Think. How this container should have a network in certain ways and accessible to load balancer. So without port duplication, without NATing, without the port duplication. Means it should be 80, it should be also 80, it should be 80, this is 80, this is 80, this is 80. So you can load balance that. Different IP, same. How can we have it? That's the second problem. Are you getting the problems in the container world? Are you getting the problem? Hello? Okay. Now I will not repeat more problems. One more problem, let me tell you. Guys, due to some reason, this node got disappeared. Network issue, hardware issues, software issues, or number of container got disappeared. So what they should do, the remaining containers should be created here in this back other machines, whichever is available, because you want X number of instance, to be available. So if the number of instance is not available and traffic is same, then user experience with that application will be down. So the question is, who will match the desired number of container with the actual number? This functionality is called idempotent, if you remember. Who will do that? So guys, like this, so did you understand the problem with the containers? Container is good. Container is good. But for the single host, when you bring the container technology to the production level, then container is not good at all because it has a limitation. And the limitation which I depicted on MS Paint, thus containers bring the scalability challenge. Is that clear for everyone? This line is understood well? Ravi, can you please mute yourself? Is that understood, guys, everyone? Yes, sir. Okay. Now next is we are starting to view data center as a campus. Ravi, can you please mute yourself? Help, noise is coming. Ravi? I think I have to mute you. I muted everyone, guys. So those who want to ask or speak up, please unmute yourself. Okay. So yes, we are starting to view the data center as one computer. So see here in this image. This image. See, Docker, look at this characteristics. This Docker is powered by multiple CPU, multiple RAM, and multiple storage. This Docker will see everything as one compute unit, right? Correct? So same way, we need a tool, we should see all this capability combined and become one compute unit. That kind of perspective we should be having. So these are the two regions and Kubernetes. Why Kubernetes? Because of these are. So guys, with that, we need to change your mindset also. This is the games between the pets versus cattle. Think about it. From last 2 days, we were spending time with the containers. That means starting the container, stopping the container, restarting, troubleshooting, logging, getting inside, accessing from outside. We were giving so much of attention to containers. That is called pets mindset. That is what you do with your pets. You play with them, you shower them, troubleshoot. I mean, everything would do that. But when you are in a production server or some cattle business, then you don't get into the kind of giving special treatment to the every pets or cattle, whatever you have. So when you are in a production or business owner, you have given a commitment to the client saying that, let's say cattle business owner has given a commitment to the client. At any given point of the time, every day I will deliver 100 liters of milk. 100 liters of milk. Now, let's say because of some reason their cattle are not performing well. So what they will do? Will you say like to your client, your end client, and say, boss, wait for a few days. My cattle is not okay. We are working on it. We are troubleshooting. We are trying to make the cattle working. Wait for it till that you have a downtime. That means till that time, we will not deliver the milk up to the 100 liters. Will you say to the client? No, you cannot say that. What you will do as a business owner? You will replace the cattle with the not working cattle with the working cattle. And at any given point of the time, you will not deliver the milk 101 liter or 99 liter. Expected is 100 liters, so you will deliver that at 100 liters. So guys, you have to change your mindset also. is not a pets business. You are not in a container anymore. You are in a large scale cattle business, or you are at the scale where you manage the container for the production. So you have to change your mindset also. By the way, who can manage your cattle business? Kubernetes. So what is a Kubernetes in short? So guys, Kubernetes is a container orchestrator. It can orchestrate container for the production in the multiple nodes. That is what we have discussed in the MS spent some time before. So it is a container orchestrator. Kubernetes is also workload placement. That means workload placement means you have a 10 nodes. Kubernetes will decide which node should be created, which containers. So that placement is being done by the Kubernetes. Infrastructure abstraction, that means you don't need to know the complexity beneath it, but it's working. It's working, it will be working like that. So Kubernetes hide the abstraction, complexity, hide the complexity, and it create an infrastructure abstraction. By the way, abstraction is one of the OOPS concept also. And also I told you cattle business story. So Kubernetes will help you to manage your desired state with actual. So this is the case with Kubernetes. So guys, did you understand what is Kubernetes so far? Any questions so far? Any question? Okay. So guys, there are some benefits also of the Kubernetes. Speed of deployment. Yes. You can deploy 5,000 containers or 5 containers within a seconds. That is a kind of power of Kubernetes. Ability to observe changes quickly.
Rajesh, sorry, Rajesh, I was speaking on mute. Workload balance between placement. Can you repeat that?
So workload placement means, see, Kubernetes will manage multiple nodes in your cluster for the production. So Kubernetes will decide, depends on the availability of resources, when I say resources, CPU, RAM and all, which node I will assign this container to be run with. So those logic is inbuilt with the workload, with the Kubernetes. So that way, when you say workload it means your application, which is your workload container. So placement is being done by Kubernetes. How? I will discuss this in architecture discussion. Getting my points, guys?
Okay.
Rajesh, is this something like load balancing, round robin or first come first serve, or something like that? Or
load balancer is, understand this one. Load balancer is for the accessing one of the application out of 100 in short way. But here I am saying workload placement. That means you have a 20 node in your cluster where you are running the production server. Now, which node the container should be created, that decision is been taken by Kubernetes, depends on some algorithm. That means, let's say you have a 10 node and you want to create a 5 container. So this 5 container should be created in which node it has some resource availability, which node it has not. Who will decide? They will decide.
Got it.
Got it?
Yeah, got it.
So guys, there are certain benefits also. Speed of deployment, yes. Deployments nowadays you can do with a few seconds with the help of Kubernetes. It has a second benefit also, and it is ability to observe changes quickly. This is interesting. So have you done any upgrade work? Many times, recently, last night only, I was doing some transaction in the midnight. around 2 o'clock at IDBI Bank. And I learned that IDBI website was working fine, but the transaction they had disabled it. I called the customer care, they said the upgrade is happening. What is the windows for upgrade? 6 hours. Just imagine 6 hours. But nowadays we are in a different world actually. What kind of world? Let's say the same story, Ola versus Uber. If Ola is not working, you'll migrate to Uber. So this is the world we are currently living in. So you have to upgrade within a few seconds without even millisecond of downtime. Yes. How can you do that? Kubernetes will help you. How? I'll show you the demo. Don't worry about the how part, because how I will teach you. For that only we are learning Kubernetes. But it has another benefit also. Ability to recover quickly. That means, let's say some of your deployments went wrong. Can you roll back within a second? It's possible without having even single milliseconds of downtime. Yes, millisecond. Can we roll back? Yes, Kubernetes will help you. And all this complexity, how this Kubernetes is taking care of it, it hides all this complexity within the cluster. That means for the end perspective, you don't need to know anything. You're just enjoying everything. So guys, this is a power and benefit of the Kubernetes. Everyone understood this?
Yeah.
Yes, sir.
Yes, sir.
Yeah. So guys, let's move on to the things which is called Kubernetes is moving fast. Guys, this is true. I am using Kubernetes from last 6 years, I believe, 5 years. And the Kubernetes which I studied at that time and what I studied now, use now, has a huge difference. So why I'm saying which difference? Architecture wise, most of the things may remain same. Many stuff, not most of this. Many steps may remain same, but many things got added and many things got deprecated. So if you really want to learn and be in line with the Kubernetes latest technology, then what you should do is you should always keep practicing Kubernetes and Docker, because it is moving very fast. Okay, lots of changes coming here and there, so it's very important. With that, we have understood what is Kubernetes. We have understood what is the definition of Kubernetes. We have understood from where it is coming from. We have understood about the why we need Kubernetes. We understand some of the benefit of Kubernetes. So now we should know how Kubernetes works. What are the Kubernetes architecture which we have? So can we go into this discussion if you are okay with it?
Yes, Rajesh.
Okay. So now let's understand the architecture of Kubernetes. Okay. Now guys, first understand the big picture view. Kubernetes big picture view. And we call it Kubernetes is an orchestrator for microservice apps. You know what is service. In fact, I discussed little while ago also. And then probably you might be having idea on microservices also. So Kubernetes is not only an orchestrator for containers. It's not only container orchestrator. It is a orchestrator for microservices also. How? Let's try to understand this. Look at this picture. This picture, you have football ground, and we have a two component. One is a manager, coach, and we have a team also. Now, we have a different team, different player. So what do you think, guys? What is the objective of this team player? What do you think? What goal? Everyone is right? Objective of this player is goal or to do something else also?
Stop the other team's goals also.
Is it? Okay. So guys, if you set a goal for each player, and that is you have to make a goal so you will win the team, win the match, then what will happen, you know? See, every player will be near to the goal post. And when you all are near to the goal post, you know that how many goals will happen. This is how we used to play in our childhood days. Correct? We used to be near to goal post and shout, "Give me the ball, I'll make a goal," and this that. And we used to angry on our teammates. But actually, that's not objective here. That's true. Objective is not to make a goal. Yes. Team's objective is not to make a goal. That is where if the team is playing like this, one guy comes into the picture, that's called manager or coach. Manager says, listen me carefully. Sometimes you call it manager, sometimes you call it coach, sometimes you call it master, whatever it is. In my school days actually, we used to call Master Ji. I don't know whether it's a Hindi word or English word, but we used to call Master Ji. But later in my school, we started calling Sir. Kind of. So yes, master, concept is good. Master, manager, coach. So this guy comes into the picture and this guy says, listen to each player. If you follow me and if you do whatever I say, then only you will be on the ground. If you do not follow me, I will pluck you out of the ground. Now manager, aka coach also understand the capability of the each player. Who's good in defense, who's good in attack and everything. Now what manager says, listen, this is a kind of plan which we have. Don't need to run too much. Don't try to make a goal. Only pass the ball to each other because you cannot run faster than ball. So your primary objective is to run the ball, not you. You need to coordinate well. So everyone needs to coordinate well with each other, and that is how the ball will run faster from the one point to another point. And then there is a two people which is in strike range. They will have the goal responsibilities or whatever it is. So this way, the team can not only play well, but also can rotate the ball faster. And those teams win who can do well coordination. Did you understand that now, goal? So what is moving here in the ground? Ball. With the help of player. Under the guidance of manager. If anyone disobey that guidelines, throw them out. Did you understand that? So guys, now convert this same situation in the service world, microservice. Remember, If you know the microservices, in SOA, service-based architecture, we had a 4-5 service, 10 service at max. But in the microservices world, when you develop a product in the microservices, you have 200 microservices. Just imagine the number. Each function is acting like a microservice. Yes. Each function. So who will manage? Who will orchestrate them? So here to manage these microservices is equal to player. And microservices send to each other what? What they send to each other?
Application.
No. They send to each other data. Request and response, sir. Right? So here microservices is equal to player, and your football, the ball which is moving between the players, is become your request and response. Now who is controlling here? Manager, coach. Who controls there? Kubernetes.
Manager
Kubernetes. And that is the reason we call it Kubernetes, the orchestrator for microservice app. Did you understand this statement now?
Yes, Rajesh.
So now you look at these guys, these players convert into the microservices and see that microservices, who's managing Kubernetes. And look at this image is interesting. HTTP, look at especially HTTP placement. One HTTPS is running in node 1 and another one is in node 2, but still the behavior is same. So this is called Kubernetes. With that knowledge in place, guys, look at this architecture. If you look at this image, here we have a Kubernetes cluster. In the Kubernetes cluster, you have a master. You may have a masters also. Why? Because if one manager and coach will die, who will manage the team? Similar concept. If one master is not functioning well, we can have another master as well. So that concept, that way, the multi-master cluster. And here you have a node. See that node. Node, it can be your physical machine, it can be a virtual machine. By the way, master also, it can be on a physical machine or it can be a virtual machine. But we call it master node, worker node, or a node, something like that. So when you say Kubernetes cluster constitutes of master and node together. Now the question is, someone is controlling master. Who is that? So there's one package you can see that controls the master. That controls the master. Who writes this package? You write. Human write. We write. I write. You will write. This package we send to master, and master control entire cluster and node and everything. So in a Kubernetes cluster, we have a master, we have a node, and we have a deployment package. So far, so good, guys. So far, so good.
That is YAML file?
Yes, that's all. Yeah. So master who is in charge and node who is really doing the work. Look at this. Now I learned node has a pod. What is a pod? I don't know. But I see node has a pod. If you see inside a pod, there any idea what is that icon is for?
Barcode?
That is the icon which is for the container. Okay, is hardcore. So here in terms of
Hearing some disturbance. Is everybody hearing the same?
not for me at least.
So there is some noise.
Yeah, I'm hearing.
Yeah, I'm hearing.
Okay, I'm not able to hear. It's coming from me.
Yeah.
Looks
Yeah,
like
I'm
it's
hearing.
you, Rajesh.
Yeah, I guess yes.
Because I'm using the same setup. There's no change actually so far. I don't know what is happening. Let me reshuffle my headphone. What about now? Is it okay?
I think during the reshuffle also we heard that looks like some headphone issue. So now again we are
Okay, now it's okay.
No, still the
we are still getting
I don't know where it's coming from because straightforward is coming wired to my head. This. Are you guys
maybe it's connected.
Not continuously, you can continue. We'll see if it is coming again.
Okay. Okay, guys. So here now, if you see that little bit complicating the architecture, if you see the Kubernetes cluster, you have a master. You may have a master. You have a node, multiple node. Node has a pod. I don't know about a pod, but inside a pod I see container. So at least I got to know container is inside a pod and pod is inside a node and node is managed by master and master is managed by deployment package. This at least I got to know. So now let's get into the little bit more. So now let's understand deep dive about master. So what is master? So we call it master a Kubernetes plane. Yes. We also call master as a Kubernetes plane. Okay. So let's understand, guys. Master can manage multiple nodes. Okay. Nowadays it can manage a Windows node also, but till 2019 Windows, they were not able to manage the Windows. So master can manage a node. Node it can be in Linux and Windows. This image need to be changed a little bit. But master need to be Linux 64-bit only. Yes, 64-bit only. Master has a 4 component. That is wonderful. Master may have a multi-master for HA. Master manages the node. A node has a pod. Pod has a container. And pod may have multiple containers. Extreme left side also. Please look at the image. Pod may have multiple container also. So now, guys, we have a 4 component in a master. Let's understand that. Okay. So now what is this called? API server. Okay. So guys, do you understand API? So here we have API server. So please read this statement and then I will explain it to you. API server. So it states API server is a front end to the control plane. Means whole things together we call it control plane, but API server is the front end to the control plane. Now you can't to reach out to API server, you have to be JSON only, consume JSON. And API server is exposed through again API, and that's called REST API. So this is a API server. Okay. Did you understand this? Did you understand this?
Can you repeat that control plane?
This whole thing is called control plane.
Okay.
master, aka, manager, aka, control plane. So guys, this is API server. Did you understand that?
See, Rajesh, I mean, one big question. So this API server will be present only on the master node, or it will be present on across all the nodes? I mean,
No, only master.
only master.
I'm talking right now only about the master.
Okay. Okay, and who decides that this node to be a master? It is handled by Kubernetes itself internally.
No, who decides that node has to be master? By you. You
Okay.
can tell, no, who's your master node, who can be overcome.
Okay. So while creating this architecture itself, we can decide that.
Yeah. One command which will make this master, and one command which will make that worker. I'll show you during the demo.
Okay, and one more quick question. So let's say this master node goes down, then what happens?
Actually, no, we have a multi-master cluster concept I discussed.
Okay. So in that, okay, fine, Rajesh.
Yeah. So now, guys, you have API server. Now let me simplify this because I don't know how many of you have understood. See what happens. Kubernetes has lots of features. This is a 1 feature, 2 feature, 3 feature, 20 feature, 30 feature, 50 feature, 100 feature. So many features you have in Kubernetes. Now, these all are you can access directly to API, different API. But you know, because it is a hundreds of features and hundreds of APIs, we will get irritated. How can you remember the so many features, so many APIs? How can I? So it's not an easy task. Then what we do, conceptually, we club it together all the API, and this we call it API server. So now instead of having hundreds of API endpoints, now we have only one API endpoint. We need to talk to only one API endpoint, not API. API endpoint. This is API. Think logically. This is the API. This is API server, which is a front end to the cluster control plane. That means any incoming and outgoing communications has to process through API server. Right? Did you understand?
Yeah, Rajesh, in that case, if any of the API call is failing, then the whole endpoint will give a failed result, right?
So any API will fail, that your request will not be entertained. So for that, we have a HA also, right? Got it?
Can you please come again, Rajesh?
So if, let's say, API server, you have a HA also. One is not responding, other will respond. Right now? HA means multiple master, multiple API server.
Okay, so we have multiple API servers as well.
Sir, I said multiple master, and master I told you very clearly.
Okay. Yeah. Okay.
Yeah.
Okay.
It's a part of the master only, right? Okay. So guys, are you okay with
No, my question was on the list of APIs there, Rajesh. So can you go to the
So conceptually, I try to explain it to you. What is the API server? So API server is one of the components where you have a multiple feature, but you can access using only one endpoint. No, that's the reason we have a server. For example, let me tell you in a simple way. Docker Hub, you had only one registry, but at that place you have hundreds of repository, right? Correct, na? Are you understanding?
Yeah, got it, sir.
Yeah. So guys, let me help you to understand in a different way. Okay, before that, I would like to share with you this image. So guys, this is the first component of master, API server. What is the second component? Please read this. I would like you to read this. What it says? Basically, it's stored. Look at the arrow also. You'll find more interesting. Second component, what we call it is cluster store. What is the cluster store? So cluster store is a persistent storage. Persistent storage means permanent storage. But for what? It stores the cluster state and configuration file. Yes. So anything which is passes through API server, sent to the master, sent to the control plane, API server is stored where? Cluster store. It is not holding with themselves. It's storing in the cluster store. Now guys, cluster store, how this is being empowered, which technology is being used. So you might be having that something like a MongoDB, DynamoDB, Elasticsearch, this, that, different storage kind of nowadays is coming, right? So like that, there is one more technology tools which is there, which is called etcd. It's open source and free. You can store here everything in a form of keys and values. So etcd is powering the cluster stored application, and etcd is a distributed. That means you can have a multi-cluster on etcd itself. It is a consistent. You can watch it at every node. And cluster store is a source of truth for the cluster. That means whatever you have in the cluster store, Kubernetes knows only that's the truth. If you have nothing on the cluster stores, that means that is not exist in the cluster. Very simple way. So guys, this is the second component which is called cluster store. Now before that, I will give you little bit of different explanation. Body, image. Look at this guys. This is the body picture each one of us have. Now tell me, if I look at the body, which can act like a control plane? See, body has multiple features.
Brain.
Huh?
Brain.
Control plane. Brain, yeah, is the storage. Memory, which is a control plane.
Nerve.
Space. This guy controls everything. Okay. Let's use today's picture. See here. This is a control plane for entire body. See here. How it works? Let's understand this. See here. Input stored. Sorry, I made it little bit wrong. Move. So all the input will go to here. Then stored will be here in the memory. Okay. This is you got a designer. Means I will tell you, or you will tell me, Rajesh,
You go and eat. Okay, eat food. So you told me I will store this in memory. Now my eyes will look for where is the restaurant. It's like a monitoring tool. Where is the restaurant? And then I will instruct to the restaurant people, give me the food. I will instruct whether I get it or not. It's a different thing, guys. But I will instruct, give me the food. So this is called control plane. One component here, storage, monitoring things, and scheduler. And these all three things works with this one. Because this only guys can update that. I mean, by the way, it's not happening in the body way, but here, if you look at the image here, now look at this. See here. 4 component. API server receives everything. Then cluster stored. Third component is controller manager. This is the controller manager. It's your eyes which controls everything and update. So here, controller manager, what they will do, they will have a multiple controller. Understand that. Controller manager will have a multiple controller, and what each controller you do, it will monitor everything. For example, we have how many eyes we have? 2. But here we have a multiple eyes, and that's governed by the controller manager. So node controller will check node is attached to the cluster or not. Endpoint controller will check that node endpoint is accessible or not. Namespace controller and blah blah blah. So what is the job of this controller manager? Watches for changes in your cluster and helps to maintain desired state. Desired state means I wanted to have something in my cluster, whether that is there or not. Simple. So you can say in easy way, this is a monitoring service for the cluster alone. Did you understand that, guys? This is your eyes. Did you understand that?
Yes.
Now last component which we have is scheduler is equal to mouth. See what it's doing. It keep watching API server. Okay. It keep watching API server. And for the new pod, what is the pod? I don't know. But one thing I know, pod is inside a node. Inside a pod you have a container. Inside a pod you may have a multiple container. This I learned. Rest of the things I don't know, so we'll learn later. So here kube scheduler watches API server for what? Request. For what? Request. Pod request. And it has affinity and T-affinity. That means this guy can schedule the work to the node. See that. Assign work to nodes for anti-affinity, affinity, constraint and resources and many things are there. So this is scheduler. In short, these 4 components coming together and is being called as a master, aka control plane for Kubernetes. Guys, did you understand the now master component of the cluster? Which is the basically brain for entire cluster. Understood, guys? Did you understand?
What is that akka here? Akka AK.
Akka means also known as.
Okay.
Okay, so guys, please read this. This is a conclusion of master. So API server is central, simple, RESTful, and updates API etcd. Cluster store is a persistent state. Key values etcd watchable. Scheduler watches API server. Schedule pods, resource and resource constant. Controller manager is also having some. Look at this little bit elaborated. Look at it very carefully. Little bit elaborated architecture. So guys, if you see the bottom section, you have a laptop. Laptop is your workstation. What do you have installed in the laptop? kubectl. Look at this. You write a package in JSON and YAML. You send to API server through kubectl. API server stored in the cluster store. Controllers keep reporting to API server about the state and configuration of the server. API server matches that whatever is reported by controller with the cluster store. If something is mismatched, scheduler go and assign a work to the node. Node has pod. Pod has container. So far so good, guys. So far so good.
Okay, on the last slide, what is update etcd does?
etcd is a cluster store, is a component name powered by etcd. Cluster store means storage technology, persistent storage. Now based out on what? etcd tool. For example, database is a storage, but for powered by MySQL tool or Oracle tool, like that. Got it?
Okay.
So guys, now time has come to look into the worker. So this is the nodes, aka minions, aka the Kubernetes worker, whatever you call it. It's up to you. Minion is a nice name. Minion movies. Have you watched Minion movies? It's one of the good movies. Now, story of Minion is completely matching with the nodes and Kubernetes worker. Okay. So those who missed the Minions movie, let me remind you. This is one of the animated movie for the kids. Now, in this movie, there is one species called Minion. So Minion is like a kind of slave species. They are born for being to do some work for someone else. Okay, like a node also is designed for the work based on the instruction for the someone else. So minions have no master, so they become sad. So what happens? Minions travel the entire world and they try to find out the master. Once they found out the master, they serve the master and debug the masters till that master gets disappeared, dies, or whatever it is. So something like this story is also. So behavior of nodes or aka worker is something similar to minions. So minions has what? So guys, minions has three important components. Let's understand that. First important component is kubelet. Can you please read this? What is a kubelet? Everyone? Kubelet. The main Kubernetes agent. Yes. So this is the agent which is running in each machine. This only registered node with a cluster. That means because of this, the we registered a node with the cluster. Watches API server. So kubelet keep watching API server. And if schedulers schedule the work, then instantiate a pod. See here. Who create a pod? I will ask you multiple times. Kubelet. Based on the request from scheduler. Scheduler get the request from API server. API server request when? When there's a mismatch between the stored request, stored data and reported by controller manager. So all are interlinked actually. Now, kubelet will instantiate a pod, report back to the master, and it's running on 10255 port number. So for every node of the cluster, you have to run kubelet. This is the agent. Without that, that node is not a part of the cluster. Very simple. Now guys, this you know more than me now. Container engine. We spent 2.5 days on this. Docker. Kubelet, container engine, Docker. What exactly is the capability of the Docker? It has, you know that very well. With that, this is the second component of the each node. Now, can you please read this? Same thing I discussed. Why Kubernetes part? I discussed this one. I discussed, remember, let me remind you if you forgot that. I think I lost the image. That question mark, remember? How can this pod accessible to load balancer without proxy? That is a requirement. So this is called Kubernetes networking requirement. Okay, this is called Kubernetes networking requirement. So here what we have, Kubernetes.
Rajesh, in the previous image, what was the third component?
Previous image?
Yeah, the kubelet, container engine and third component.
That is what I am talking about. No, this is.
Okay.
So giving you context for it. Remember, the containers were not accessible to the load balancer. So how can we access container to the load balancer? So yes, Docker has limitation. But what about container? So here you see in Kubernetes, container is inside a pod. What is a pod? I don't know, but container is inside a pod. And then we got a requirement for networking in Kubernetes. So we can load balance the pod. What are the requirements? See here, please read this. All pod can communicate with each other on all nodes. Means all pods can communicate across the network on the every node. All nodes can communicate with all pods. That is also done. And no NAT is required. No proxy -k this data. So how can this be possible? This is possible because of kuproxy. Yes. So kuproxy is the real component which helps you for the Kubernetes networking services. Kuproxy is a Kubernetes networking services. And you know one thing, here in the Kubernetes, yes, in Kubernetes, container do not get IP address. I repeat, in Kubernetes, container do not get IP address. Then you must be wondering, whom getting IP address? Pod. Who assigned this IP address to pod? Kuproxy. So kuproxy manages the IP address of pod and all containers in the pod, because I said, what is a pod? We don't know, but one thing is we know. Inside a pod, you may have one or multiple containers. So here, all containers in a pod share a single IP. And because of kubeproxy only, this load balancing is possible. So kubeproxy is the third component of the worker node. First one is kubelet, second one is a engine, Docker engine, and third one is a kubeproxy. Guys, did you understand this? Did you understand this?
Rajesh, it means like we have node 1, node 2, and in node 1 we have multiple pods, node 2 we have multiple pods. So node 2 can have access to, can communicate with node 1 pods, and also pods in different node can communicate with pods in different other nodes, right?
Yes, that's correct.
Okay.
Because of kubeproxy. See guys. So ultimately, three components: kubelet, main Kubernetes agent, container engine, Docker or Rocket, kubeproxy, networking services. So guys, look at this image, please. I will suggest you to spend few seconds. Yes. Guys, did you understand this now? Any questions? Any questions, guys?
Container runtime is nothing but
Docker.
Yeah.
Rajesh, don't we have any disadvantage if all the containers in a node share, all the containers in a pod share the same IP address?
No, that is the requirement, no limitation with the Docker container, remember? Because of that, load balancer was not working at all. Because of container is good for saving the CPU, but it's not good for the production. So we created a wrapper around it, so we load balance well.
Okay, it means Docker alone is of no use. It should be tied with Kubernetes or anything to make it function better, right?
Yeah. So look at this, guys. Please read this. Kubelet, kubeproxy. Please read this. It's important. Don't ignore.
Rajesh, remember earlier you told that network load balance has a unique that need to have same port number, right?
Yes.
Here also, since the container not having any individual IPs, it will be the pod level.
Yes.
So, a pod you will assign one IP with multiple containers with same port.
No. To Apache, you cannot run in one pod. Because the same port. No? You have to run Apache or something else on other port. For example, I'll put it in this way. In the one laptop, can you run two Apache on the same port? No. Similar way, you cannot run. You cannot run two Apache in the same container also. Same way, you cannot run two Apache container in the same pod also. Against the concept.
So the principle is same across anyway.
Okay, guys. So overall, in the cluster, we see few more components. We will not emphasize more on it, and the reason is slowly we'll learn DNS servers, ingress, dashboard. These are called add-ons. These are not the core components, add-ons. So guys, we understood the master and worker. Then we need to understand the workstation, the human, what they do. So I've been telling you, we write a desire, YAML file or JSON file. We write a package, deployment package.
So how do you write that package? That is the question. How do you write that package? How do we write those packages? Declarative model and desire state. So first you decide what you want. That is called your desire. Understand that? Very simple logic. First you decide what you want. That's your called desire. And whatever you desire, declare in the declarative model language. And that's called YAML. So desire state and declarative model. So here, you see here, you have API server. So what you do? You write a desire. In what? YAML. Declare it. Send to API server. What you want to desire? So see here, you desire 3 pod of what? Nginx. 3 pod of Nginx. And guys, look at this. In your cluster, you got a 3 pod in the node 1, 1, 1. It's so simple. But how it works, you know that. You created a YAML, sent API server. API server stored is a KB stored. Controller suggested saying that there is a 0 Nginx pod. API server instructed the scheduler, go ahead and schedule the 1 pod, and the scheduler assign 1 pod to each node, and kubelet receive that request, kubelet initiate a pod, and then Docker fill the container inside that, and then kubeproxy can assign the IP address to the each pod. Work is done. Are you able to understand the whole workflow now? Whole workflow now?
Yes, Rajesh.
Yeah. So now, see here. Suddenly what has happened, guys, due to some issues, one node got disappeared, hardware, network, this, that. So immediately controller manager said, boss, I have 2 nodes but 2 pods. It reported, controller manager reported to API server. API server said, okay, in my etcd store there are 3, but you are reporting 2. There's some mismatch which is happening. So what do you do in this case? What we do in this case? So in this case, again same things. Mismatch happened. API server instructor scheduler, go ahead and create a 3rd pod of Nginx. Scheduler assigned to the kubelet, one of the node available. 3rd pod got created. Actual versus desire is matching. Everyone is happy. Who did it? You did not do that. Kubernetes did that. That's where you get the good line. Guys, did you understand that?
Rajesh, can you again repeat?
See here. Due to some reason, the node got disappeared. So desire was 3, actual was 2. So again, controller manager will report back to API server. I got a 2. API server will again check the etcd. 3, desire. 2 not matching is equal to 3. So API server will go and say, scheduler, create one more pod. Scheduler will select one of the node, available node, and assign that work to the one of the node. In the node, what do you have? Kubelet. Kubelet will assign that create a pod. Docker will fill the container, and kubeproxy will do the IP addressing stuff, networking stuff. And then everyone is happy. Done. Now you understood, guys?
Yes.
So how many pods can a node hold?
Hello?
How many pods can a node hold, Rajesh?
How many pods? It depends on your desire, right?
By chance, the node also is not working. Again, it will do the same thing and put all the 3 pods in one node, right?
Yeah, 3 pods in one.
So why do we have
Don't
multiple?
create any new node, Rajesh.
What is that?
The pod will be created inside the already existing node only. It won't create any node.
No, it will not create a node, new node.
Okay.
It will fill the pod. Who will see? Think about it. Logic.
logic. I think I understood your question, but you are not thinking. See here. This is your cluster. Why this not I'm able to type? What happened? Okay. So guys, look at this here. Scheduler is playing a very important role. 1 node, 2 node, 3 node. Okay, 3 node cluster you have. It's filling the data. Scheduler knows everything because of controller. Keep reporting. So scheduler means scheduling capability it has. So has this some threshold? If you have more than 80%, you can set the threshold how many maximum pods you can hold. Again, I'm saying scheduler you can set a threshold. So you create a 1 pod, 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 1 pod. So 4 pod, 4 pod, 4 pod. Now you said that it should not. You should hold the container pod only till the your CPU is 70%, something like that. There is some default setting is done in scheduler. Okay, you can also customize it. Now after that 12 pod, you desired 15 pod. So where this 3 pod will be going? So this is beyond your capability, right? So what will happen? This 3 pod will be going to pending state. Pending means and yet to be allocated node for it. Node is not available. Now you must be wondering, okay, fine. 15 pod I wanted, 13 pod got created, 12 pod got created, 3 pod did not get created. So fine, it's pending. Can't it be done new node? Guys, adding a node is not under the Kubernetes perspective. Who will do that? If you know AWS, auto scaling group will do that. They will monitor this node, this node, this node through one security rule. And the moment they see average CPU utilization is more than 70%, they will add a new node and they will attach to the master. So this is ASG work, not a Kubernetes work. Kubernetes only the plan the pod inside the worker which is already attached to it. So did you understand that?
Yes, Rajesh.
Rajesh.
Yeah. So guys, this is how it works. So what do you want to learn? Because everything is, I've been telling you everything is done by Kubernetes only. So what you will do? So guys, you will do only one thing next 2 to 3 days. You will learn what are these features available. Simple. Read my statement. What are these APIs available? Features available in API server, which you can use it and do the CRUD. That's all. This is API server. These are the features. These features, what is this? Pod. X, Y, Z, M, and P. All these features you need to know. Such as these features we call it. Now you need to know what you can declare in the YAML, which will be created by API server. What are the features you have in API server? So those features, first important feature is being called pod, which I have been discussing since afternoon. So you need to know pod, controller, services, storage. By the way, this is not exhaustive list. These are the key players. Like that, you have more than 50, 60 resources you need to learn. So basically, guys, everything will be done by Kubernetes, except you need to know what you want, and for that, we will spend. So now we'll discuss about what is a pod. So now,
Rajesh, before that, so how many pods in a node? Who will decide? Kubernetes has the control.
what is that?
How many pods? So imagine like in the earlier example, there were 1 or 2 nodes that were not functioning. So Kubernetes put the pods in a different node. So will Kubernetes have the
Sir, your voice is breaking. What is the question?
Yeah, I mean on the nodes part. So how many pods should be there in a node will kubelet be the person who decides that, or who will decide?
Scheduler, sir. Always I've been telling you, only scheduler decide which node to be assigned with. And can you change the scheduler? Yes, you can change the scheduler logic.
Okay.
Scheduler assign the work, right? Kubelet, see, kubelet is a minion, he is a worker, he will slave. He will not decide anything. Everything is decided by master. Components. Right, guys?
Okay, Rajesh.
Okay. So now,
Thanks for watching. If you liked our Kubernetes session so far, please enroll for our channel membership 399 plan to get access of all the parts. Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devops.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the 399 plan and grow your skills immensely. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.